Hello everyone. Yes, I am bald now. We are going to be looking at the next part of our circles unit, which is to be writing and interpreting the equation of a circle. That means we're going to be drawing circles in the coordinate plane like what you see before you. So what's really important to me is that you not only know what the equation of a circle is, but also kind of understand where it comes from and why it is the equation of a circle. In order to do that, I want to take a trip down memory lane to 7th grade when we first started writing the equation of lines. I've got a line right here. Now I'm going to ask you to pause the video and do two things. Write the equation of this line in slope-intercept form, and, as a review from what we did earlier in the year, write the equation of this line in point-slope form. Do both of those right now. Okie doke. So, let's start with the easy one, which is slope-intercept form, because that's what you've done for years. We know that slope-intercept form looks like this, y equals mx plus b. Now we don't like leaving our equation like that. We want to replace the slope and the y-intercept. So we would look, and in this line, the y-intercept is 1, and my slope is 1/2. Then we leave the y and the x in there. And we say, okay, that there is the equation of this line, but there's also point slope form, which looks like this. Y minus y1 is equal to m times x minus x1, where the x1 and y1 are any point on that line. So I'm just going to pick an easy one there and just choose 2, 2. Try that point there. Sorry if you hear that generator outside of my house right now. So I would have y minus 2 is equal to 1/2 times x minus 2. And that I will also be happy with calling the equation of this line. Now remember, with point slope form, these numbers, the x1 and y1, can be replaced with any point. You could have plugged in the point 1 and 0 here, or a point up here, a point down there, whatever. But the point is, those are two ways I could write that equation. Now let's talk about why that's the equation of the line. How do you know you have the correct equation of a line? Well, remember, the whole reason we leave that y and the x in the equation is because we can plug in a set of coordinates into that equation. And if that point satisfies the equation, if it makes the equation true, then that is a point on that line. So let's pick that point I highlighted earlier, and let's plug that in up here. Is 2 equal to 1/2 of 2 plus 1? Well, is 2 equal to 1 plus 1? Oh dear God, I hope so. With everything that's going on in the world around us, if that weren't true, I would break down and cry. Let's try a different point. How about this guy right here? Well, its coordinates are 1, 2, 3, 4, -1. Let's plug that into this equation over here. Again, my y is -1 minus 2 is equal to 1/2 of 4. Oh, that should be a -4. Bad, Lasella, you made a mistake. Minus 2. So that would be -1 minus 2 is -3. Should be equal to 1/2 of -4 minus 2 is -6. My Google Home is talking to me. Yes, -3 is equal to -3. So in other words, we know that those points are on the line because they make that equation true. Likewise, I know that that equation is true because I can plug in any of these points and they're all going to make that equation true. Using that idea of something that satisfies the equation, we're going to kind of back engineer our way into finding what the equation of a circle is. So to start off, I need to draw a circle here. And I need to make sure that when I draw it, I'm drawing it in a way that I've actually got my center on the grid, so to speak. And I think I've bloody gone and done it right there. So here, I've got a circle, and I know where its center is. So to start off, we know that the definition of a circle is the set of all points equidistant from a center. So there's two things you need to know whenever you're talking about a circle. You're going to need to know its center, and you're going to need to know what that set distance is, which is known as the radius. So in this case, in this circle, my center is the point 1, 2, 3, comma 2. And my radius, that distance that all the points are from it, in this case is 5, because I can go 1, 2, 3, 4, 5 and get up there. Or I can go across 1, 2, 3, 4, 5 and get over here, or even to the left, so on and so forth. Not only are those 4 points that are in those cardinal directions, not only are those on the circle, but I've also got points all along here that are on it as well, and they are all a distance of 5 units away. So let's use that information to let us come to the definition of a circle. So to start, circles are all about that fixed distance. It's why a compass works. So if you remember, we had a tool that we used, or an equation, a formula, that let us find the distance between any 2 points. That formula was the distance formula, which looked like this. The distance between any 2 points is the square root of x1 minus x2, or usually I gave it to you guys backwards because it just made the math a little bit easier. x2 minus x1 squared plus y2 minus y1 squared. And if you remember, we found that by really taking right triangles, because let's say I had a point here and I had a point there. Well, if I treated that as a right triangle where I said here's x1, y1 and x2, y2, I could find the distance between them by saying, okay, let me find the distance between those x's and the distance of those y's, square them, yada, yada, yada. We've done that. We know that. It's cool. So how does that help us here, dude? Well, I'll show you. We're going to say, let's substitute what we know into this problem. In other words, the thing I definitely know for sure is the center of the circle. I need to know that center, which is 3, 2. So that's my first point. Then let's try to measure, instead of measuring directly to this point, whose coordinates I know easily are 3, 7, or to this one, whose coordinates are -2, 2, instead, let's measure to some obscure random point. Like, let's say this guy here. I don't know the coordinates of that off the top of my head because it's not exact, right? So it's just some random x, y, just a generic point. So let's plug in what we know into this distance formula here. First of all, if I'm measuring from here to here, I know that distance because that point's on the circle. And any point on that circle is a distance of 5 away. So I'm going to say 5 is equal to, and let's say this is my x1, y1, this is my x2, y2. I'm going to say, well, take one of those x coordinates and subtract off how far away the other x is from it, squared, plus one of my y coordinates minus the other y coordinate I'm using as a reference. We're actually really, really close here. Because if I want my general form for the equation of a circle, I want it to look a little bit prettier than this. I don't want a square root, in other words, so I'm going to square both sides right now. And when I do that, I would have a 25 here, and this square root would go away. Before I do that, I'm going to rotate this thing around. I'm going to put my x's and y's first. So when I square both sides, the square root drops out, and I would just have x minus 3 squared. That squared is still there, because all I'm doing is I'm taking this, raising that to a power of 2, which just crosses the 2 out, plus y minus 2 squared, and since I squared both sides, that's going to equal 25. As ugly as it may seem to you at first, this here is the equation of the circle we just drew. That's the way we present the equation of a circle. Again, I know it's not pretty, it's kind of ugly looking, but it actually makes a lot of sense when you dive into it a little bit. Because what we would do in general, if I wanted to write the equation of a circle, is I would say to myself, well, where is the center? In this case, it's 3, 2. Then I'd say, how far apart is it? 5. So then that would mean if I plugged my center and any point on that circle, like a generic x and y, if I plugged it into the distance formula, it better satisfy that equation. So let's test it with some of the points I have here. First, let's test this guy up here, which is going to be really simple. Let me plug that into the equation of the circle I just drew here. Well, I would have my x coordinate, which is 3, minus 3 squared, plus my y coordinate, which was 7, minus 2 squared, should equal 25. And sure as sugar, 3 minus 3 would be 0 squared, so that term cancels out. 7 minus 2 is 5 squared, plus 25. Oops, not plus 25. That should equal 25. And wouldn't you know it, 25 equals 25. So since that point satisfies the equation, that point lies on the circle. Let's do one that's a little bit more fun. Like, how about this guy right here? Now, I want to ask, is that point on the circle? Because if you look up here, you see the circle just kind of misses the grid there. Maybe it's doing the same there, but it's so close that my screen can't actually show that it's not directly on it. Let's test it. Let's plug it into this equation and see if it makes that equation true. So I'm going to go ahead and clear out what I just drew, and let's test in there. So first of all, what are the coordinates of this point? This point is coordinates 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6. Hey, that's easy. 6, comma 6. Let's see if that point is on the circle. To know if it's on the circle, I'm just going to ask myself, is the distance between the center and that point equal to 5? Now I could do that. We've done questions like that before by plugging it into the distance formula. Instead, let's plug it into the equation of this circle. Let me say, okay, the x coordinate I'm measuring to has an x coordinate of 6, so let's do 6 minus 3 squared plus y minus 2 squared should equal 25. And let's double check that. Well, 6 minus 3 is 3 squared plus 6 minus 2 is 4 squared. And if you're already ahead of me, you see 9 plus 16 here. Sure enough, since 25 equals 25, that point, 6, 6, makes this equation true, which means that point is on the circle. I know for a fact it is on that circle. So let me give you the equation in a more general term, the way it's usually given to you, because the same way we would say, oh, the equation of a line, and people say y equals mx plus b, there's not a single number in there. You know where to substitute numbers. You substitute in the slope and the y-intercept. We do the same thing with a circle. So the general form, the way it's written, is you still have those x's there, squared, and you still have the y there, and you still have the squared, equals, so this is just like the one we just had a second ago. We know that on the right side, we always write the radius as being squared. And the letters we use for this equation is we use h and k. So we would say the equation of a circle is x minus h squared plus y minus k squared, where h comma k is the center of the circle. So let's draw another one here. Let me go up here. Let me try to make this one nice and fun for us. Boom. So I'm going to go ahead and I'm going to see that this point here is the center of this circle I just drew. So go ahead and write down, wait, am I correct in saying that? Or am I off? I think I might be off. How about this? You tell me if I'm off. You go ahead and write the equation of that circle. So, first of all, let me make sure I labeled that center correctly. If I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I didn't draw this circle very well because that means the center is actually right here, right? Because I'm 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so unfortunately, this isn't a very clean or pretty answer because my center is right there. But you know what? We can still do that because not everything in life is pretty and happy and fun. And sometimes you got ugly looking things like this. So let's plug it into our formula anyway. Let's figure out what is the center of this circle. Well, the center here is 0.5, comma, 1.5. That's my center point. And my radius is 1, 2, 3, 4, 5, 6, 7, 8, 9. I thought it was 9.5. 1, 2, 3, 4, 5, 6, 7, 8, 9.5. And a half, yeah. So my in here, my center is 0.5, comma 1.5. That's my center. And my radius is 9.5. So I would plug into this equation x minus 0.5 squared plus y minus 1.5 squared is equal to, and then I would actually square the 9.5. I wouldn't usually leave it as 9.5. And I get 90.25. And that would be the equation of this circle here. Again, sorry it didn't come out very pretty. I was rushing. I just made up a circle like that. Let me try to make one that actually falls on the grid this time. Should we make a nice little small guy like that? Yeah, let's make it nice and small. Give me the equation of that circle. So, hopefully you identified the center as being right here. My center is 0, comma 1, and my radius in this case is 2. So I'm going to plug into the equation of a circle. It's going to be x minus the x coordinate of the center plus y minus the y coordinate of the center should equal the radius squared. And we'll clean that up a little bit. We're actually going to write it as x squared plus y minus 1 squared equals 4. Now that there is the equation of this circle. I know you're not used to seeing equations where the x and the y are on the same side, but that is the way we demonstrate these and present them for the reason that it is similar to, and it kind of reminds us of that distance formula. We like doing that because it's kind of pretty in the sense of it expresses the idea that's actually going on behind the scenes there. It is possible to rearrange this in a y equals format where I could subtract the x squared from both sides and get y minus 1 squared is equal to 4 minus x squared. And then I could take the square root of both sides and have y minus 1 equals the square root of 4 minus x squared, and then add my 1 at the end. Now I would have to make sure I'm taking the positive and the negative root there. Y equals plus or minus the square root of 4 minus x squared plus 1. Oops, plus 1. If you took that and you plugged it into your TI-84, you would have to do it as two lines, one with the positive square root and then one by shoving a negative in front of it. If you did that, it would trace out our circle, I promise you. So that is the first half, which is you've been given a circle, and I'm asking you, give me the equation. Let's do it the opposite way. Let's say what I've told you is graph the following. X minus 8 squared plus y plus 3 squared equals 36. And you were told, graph this thing. Well, again, because it's a circle, The same way with when we asked to graph a line, we were like, I need to know what the slope is. I need to know what the y-intercept is. Same deal here. I want to know what's the center and what's the radius. So in this circle, my center is, remember, since the equation of a circle is x minus its x coordinate plus y minus its y coordinate equals the radius squared. It's just like when we did those point slope form equation problems. The center is being subtracted off. So that means the center is a positive 8, negative 3. And my radius is the square root of 36. They always, always, always on standardized tests try to mess you up and make you think that the radius is 36. It's the square root of that. Having this now, when I go to graph it, I'm going to say, okay, let me go to my center of 1, 2, 3, 4, 5, 8, negative 3. There's my center. And now I'm going to graph the circle by going up 6, 1, 2, 3, 4. And I'm actually going to point all those cardinal directions. 1, 2, 3, 4, 5, 6. Down 6. And unfortunately, I've run out of graph here, but 4, 5, and 6 is somewhere in this little realm here. And then if I were graphing this on paper, I would actually take a compass, center it on my center, measure it across, and then I would actually draw it. Instead, right now, I'm just going to freehand it here. And then that would give me that circle being graphed. Now, I just want to point out, make sure everyone remembers that you can't measure distance on the diagonal like this, because if I go across 1, 2, 3, 4, 5, 6, this point here is not on the circle. So don't do that. Only go up, down, left, and right, and then go ahead and swing it. So sometimes you might be given an equation and they might be like, is it graphed right? In which case you make sure the center is correct and the radius is correct, and then you're done. So thanks for tuning in here. Hope that cleared it up a little bit, made a little bit of sense. If not, reach out to me, ask a question as always. See you guys around.